Hi guys, this rolling is also a very good important topic where most of the questions are asked in the previous years were asking these kind of questions. So it's so simple, you have some concept or knowledge regarding this chapter. So I already in my all videos I have said that when I was solving the rotational dynamics you just have some concept or knowledge. So the rolling is totally about your concept, how you understand, then you can easily solve those questions. So what's it said to be a rolling? It's a rolling is a combination of two things. What's the two things it said? One is rotation, another it is translation. These two reinforces and forms a rolling. When these two happens, then it's said to be a rolling. Now we discuss what's that rotation, what's the translation. The simple thing, I just want to tell you that what's the translation plus rotation, it's said to be a rolling. Now, just I'm going to tell what's that rotation and what's the translation. Just give some diagrammatic view on this. This part. Now, these assume these to be a translation motion and these to be rotation motion, and finally this is a rolling. It's rotation and this is a rolling. It happens now. You see that translation is simple like a body that seems to be move a continuous motion, that seems to be like moves with a continuous acceleration or some continuous velocity. It's moving, simply it's moving. But what's the case of rotation? What's the case of rotation? It's simply a body, it's simply a rotating. Okay, now in case of rolling, just in both these happens together, it's rolling and as well as moving, rolling as well as moving. So the rolling is a combination of translation as well as rotation. When these two happen, then it's rolls. Okay, just got a concept of knowledge. Now we can just discuss its parameters and formula. So when there is a translation motion, its entire body seems to be have a velocity in one direction. It's all about in motion in a 2D. It has always velocity in this one direction. Suppose the object seems to be moved when it's moving in a translation motion. Its entire system and entire body it seems to be have its velocity in only one direction. What's the direction of its velocity? In this direction. In this direction it seems to be an velocity. In this direction it has some velocity. That's what I'm making it here. Even at this point, at this topmost point, or at this point, even at this bottom point, even at its center, as a velocity v. But in a case, when it by suppose this seems to be a rolling. I'm just using a different color to mention differentiate translation rolling. Here, when it's rolling, this was the rolling case. This was the rolling. How it rolls. So this is what rolling. So at this point, it seems to be velocity in this direction. At this point, its velocity seems to be in this direction. At this point, its velocity seems to be in this direction. At this point, its velocity seems to be in this direction when it's rotating in this direction. It's a rolling case. When it's rotating, this is the case. When it's rotating in this direction, velocity at this different point would be this. So when these two reinforces, it's said to be a rolling. So in a case of rolling, at this point. So these two going to reinforce. First thing is translation along this direction, and next thing is rotation, it's also along this direction. So this is also v and this is also v. So when it is rotation, you already knows that velocity, we have some another formula. What's that? V equal to omega into r. Okay, whenever it's not a rotation or a simple thing, we already knows that a tangential and velocity is equal to omega into r. This is what we discussed in a previous chapter, that is circular motion. So at this point, a velocity for translation, velocity for rotation or seems to be in the same direction. So these two reinforces, and finally what it forms? It forms 2v r 2 omega r. You got that idea? Is that? So at this point, both the velocity for translation and rotation or seems to be in the same direction. So hence it has 2v. Suppose for different cases, for a point 2, now you see at this point rotation seems to, in along translation velocity, it seems to be in this direction. Translation velocity seems to be in this direction, but rotation velocity seems to be in this direction. Rotation velocity along seems to be in this direction. So it's a vector quantity. So net velocity seems to be in this direction. The net velocity seems to be in this direction. Net velocity seems to be in this direction. V resultant. What's the V resultant value? It's root 2V. How I make this root 2V? It's simple. This is a vector. When you are dealing about the vector, this is what the formula V resultant vector formula is. I'm just making it here. Or some other page I try to make it at. I'm making. What's the V resultant value? When there seems to be two vectors, a vector and B vector. The resultant vector, I just want to find it out. The resultant vector formula is root of a square plus b square plus 2ab sin theta. ab sin theta. So at this point I am going to see that here translation velocity seems to be in this direction, the rotation velocity seems to be in this direction. So these two are in opposite direction. The net velocity, it seems to be 0. So at the bottom, its net velocity seems to be 0. Okay, because these two vectors seems to be in opposite direction, and these two vectors are equal vectors in magnitude and as well as in direction. Direction seems to be opposite, but its magnitude seems to be same. Since they are an opposite vector, definitely the resultant vector seems to be 0. Now for another case, at this point now we just see its velocity seems to be in a translation velocity seems to be in this direction, and rotational velocity seems to be in this direction. So its net velocity seems to be in this direction. What's that? As like that, same. It's also v, this is also v, and the resultant velocity, and this theta will be a 90 degree. So net resultant velocity seems to be a root 2v. We just got it. So I no need to solve all these. Likewise, you don't need to solve. There's a brief idea, but I can give you a short trick without using this, without playing all these through. Just I simply give a short trick on this. Just think, now simple as short trick. Without making all these things, I just directly I can bring the formula of velocity at different points. That's how. So simple, very simple. You just assume this to be a point of contact and a ground this to be a point of contact. Now what's the formula is wherever the point, wherever you need to find, what's the formula is, suppose you assume this to be the point where I need to find. So this is the point where I need to find. This a formula is omega into distance between the point and point of contact. That's all. That's that. The omega into distance. What's the distance here is a distance between the point of contact and wherever the point you need to find. Suppose this is a point we need to find. What the distance of this? This distance is center. This is r. So this distance must be 2r. So what's the value at this velocity is omega into what's the distance is 2r. 2r, finally 2 omega r is equal to 2v. So 2v, here also 2v. That's what we get. So simple. Suppose I need to find at this point. What's at this point? Here, what the formula is omega into d. It's a distance. This is the distance. This was the distance. How to calculate this distance? Suppose this to be r, this to be r. I can use the Pythagoras theorem where the hypotenuse square equal to side square plus side square, where I can get root 2r. So I make it here omega into root 2r, root 2 omega r. Finally what I get? Root 2v. That's what I get. So at this point I need to find here omega into distance. What the distance value? At distance is 0. So the velocity also seems to be 0. Same for all those points. Wherever you need to find, you just make these tricks. Okay. Just move on to another topic. That's another topic. That's all. Our topic gets to be over. Let's see the different questions. Okay. Or another topic also. It seems. Same like that, what I discussed in the previous topic, that angular momentum is conserved and energy also seems to be conserved. Same like that, I am making it here for a rolling cases, how this formula of conservation differs. Suppose for a total energy, so total energy in rolling, it's conserved. Total energy for rolling is conserved, but in the rolling cases it will have both translation and rolling. So how I can make it, how the formula of simply what I can make for a kinetic energy. Suppose the energy is conserved. In a previous topic we just used the potential energy plus kinetic energy. This is constant. This was in previous idea, but in case of rolling how it differs, so simple. It comprising of translation as well as rotating. So how I can make it? We already know that whenever the object seems to be moving, it has some velocity. It all seems to be in the same direction. So as I said, make of mv square. For rolling, so for rotating, of I omega square. This is what the formula. This is equal to total energy. This total energy is conserved. Okay, whenever the object seems to be rolling, its energy equal to total energy equal to half mv square plus half I omega square. This energy must be conserved. It's like a total energy. Its angular momentum also seems to be conserved. What's that? Angular momentum also in rolling cases conserved. For the previous cases, how the angular momentum is conserved, I mentioned that L equal to mvr equal to constant. This is what I just make it for previous topic. Okay, but in conservation of angular momentum in the case of rolling, it's like same. This also differ. What's that? For translation, it's mvr. For a rotating cases, it's I into omega, that is total angular momentum. This also seems to be conserved. That's why. For the previous cases, we just discussed mvr equal to constant or I omega equal to constant. But in case of a rolling, mvr plus I omega equal to constant. That's total angular momentum seems to be conserved. Okay. Now the most important topic where the problems are often asked in a NEET or JEE. That's rolling in an inclined plane. What's the rolling in an inclined plane? In an inclined plane, most important topic. Nothing to be remembered. Simple thing just you want to remember. What's that? Post distribute and where an object, circular object, it rolls down the plane. It rolls down the inclined plane. Now, what's the question is, what's the acceleration of this object supposed to be rolled and comes down the inclined plane? So for this you just know only the formula. So simple thing you just want to keep in memory is that formula. There's no need of derivations. Whenever a new NEET students or a JEE student or even for a board student, stop reciting the derivations. No use of it. It's a simple thing. That's learning a derivation is not a big deal. Each and every person when you are studying in high school and even in your school classes or in your boards, often they teach us only the derivation, but physics is not all about the derivation. You just want to come out of all these words. It's all about the concept and how you understand and how to use those formulas for different problems. Physics total about problems and how you deal about it. So you guys stop reciting derivations. What you require, how to use the formulas for different cases and learning the concept of it. That's what the important thing. If you want to learn the derivation, there are a lot of websites. Just type, the often it comes. So each and every person, it's common thing was studying 11th standard. They know only the derivations. If you end of the year, end of the 11th standard, you just ask, I know only derivation. It's a case of me. I just same thing I had done. But I have completed my 12th. But later I understood this is not a real physics. Learning a derivation is not a real physics. What's a real physics actually? That you want to learn the how to learn the concept and how to use those formulas. What's the end of the derivations? End of the derivation all about the formulas. So that's what important. So please stop reciting the derivation and use how to learn the concept. You just want to learn concept and how to apply those concepts in your problem. That's what I just want to give you only the formula. This is what acceleration is, so simple formula. Mg sin theta by m plus I by r square. This is what the formula. Very very important formula. When these formulas should be used, there should be a clear word in a question. The object is said to be rolling. So whenever there is a rolling, then only you should use these formulas. Suppose they use the word it's slipping. Now if they're using the word slipping. Slipping is totally not about rotational dynamics. You just want to come out of all these things. There is no rotation, only the translation motion seems to be there. So if the question they use the word slipping, whatever the cases, you just want to think out of the rotational dynamics. Okay, just you move for a motion in a plane or motion in a 2D or motion in a 3D. Okay, just you move for those. Because whenever they said slipping, you just don't stand with rotational dynamics. Because whenever they are slipping, there is no rotation, only the translation motion seems to be there. Suppose in this case, now you find that you already also knows that. Suppose this is to be slipping. Now there is no rotational motion. What's its acceleration? What's its acceleration? There's simple thing just we have discussed in the motion at 2D. Suppose whenever the object is comes down, So this is a case of slipping, not a case of rolling. Okay, I just only giving an idea about it. There are some mg toward this direction and normal force toward this direction, and this must be theta. Suppose these to be theta, and these to be mg cos theta, and this must be mg sin theta. So this is the direction of motion. I am applying a Newton laws of motion here. Mg sin theta minus 0, there is no upward force because there is no friction force here. There is no friction in these cases. Minus 0 equal to mass into acceleration, and mass cancel, and acceleration equal to g sin theta. That's what. From these formula also I can make these formulas. How? Suppose you assume this, there is no slipping. So suppose this case of slipping, hence the inertia would not be there. So for any object there is no inertia, so this term becomes 0. I just simply cancel out this m and this m. What I finally get is g sin theta. From this formula also I can get this. Further, you just knows the conceptual knowledge. Simple thing. Okay, let's move on to a question regarding these formulas. That's the question is. A solid sphere of mass m rolls without slipping. Here they use the keyword that without slipping. So without slipping means what's that? It says that it totally about rotation. This is rolling down. It's rolling down. Without slipping means what's that? It's rolling down on an inclined plane of theta. The linear acceleration of the sphere is what? What is the linear acceleration? Simple thing. Now they ask like we already know that what's the formula of linear acceleration? Mg sin theta by m plus I by r square. This is what the formula. What is the inertia of sphere? Simple thing, I equal to 2 by 5 m r square. 2 by 5 m r square. I'm just substituting this in these terms. I get that equal to mg sin theta by m plus 2 by 5 m r square by r square. This is cancelled. I just taking m common in these. So mg sin theta equal to m by 1 plus 2 by 5. This m and this m will be cancelled. So I get g sin theta by, just cross multiplying here, 7 by 5, then 5 g sin theta by 7. This is what my final answer. So simple, you learn these formulas, then this question will be over. You don't need to think of anything. Whenever they use the term without slipping, it's totally about rolling. That's what. That's all. This chapter gets over. That's all about topic. So I make another session. That's a problem solving session on these topics, where some deep conceptual knowledge problems and all these topics, entire rotational dynamics, I just want you to solve. So kindly watch those topic also. Those questions are very very important. I just comprising an entire rotational dynamics. I'm going to ask those problematic session. So that's all guys. Rotational dynamics gets over. Bye guys.